Hello everyone, welcome to my channel. Today I will be explaining 0620 Chemistry, Chapter 1, States of Matter. Chapter 1 consists of two subunits, 1.1, Solids, Liquids and Gases, and 1.2, Diffusion. Let's move on to the objectives now. 1. State the distinguishing properties of solids, liquids and gases. 2. Describe the structures of solids, liquids and gases in terms of particle separation, arrangement and motion. 3. Describe changes of state in terms of melting, boiling, evaporating, freezing and condensing. 4. Describe the effects of temperature and pressure on the volume of a gas. Students taking supplements will also be learning about changes of state in terms of kinetic particle theory, including the interpretation of heating and cooling curves, and the effects of temperature and pressure on the volume of a gas in terms of kinetic particle theory. Solids have a fixed volume, high density, definite shape, does not flow. Particles are tightly packed in a regular arrangement. Vibration only. Liquids have a fixed volume. Density is moderate to high. No definite shape. Takes the shape of the container. Flows easily. Particles are close, are touching. Random arrangement of particles. Particles slide past each other. Gases. No fixed volume. Expands to fill the container. Low density. No definite shape. Takes the shape of the container. Flows easily. Particles are far apart. Random arrangement. Particles move rapidly and randomly in all directions. Here's a picture showing the changes in states and the names of the processes. Change in state from gas to liquid is called condensation or liquefaction. Change in state from liquid to solid is called freezing or solidification. Change in state from solid to liquid is called melting. Change in state from liquid to gas is called evaporation or vaporization. There is one more change of state known as sublimation, where it is seen in some solids that change their state directly from solid to gas upon heating. Now we will be looking at how temperature and pressure affects the volume of a particular gas. Increasing the temperature increases the volume of the gas, and increasing the pressure decreases the volume. Note that students taking core do not need the details to why it happens. And for students taking extended, will need to know details which is related to kinetic particle theory of gas. Let's move on to kinetic particle theory. Some key points you have to know is that number 1. All matter is made up of very small particles. Number 2. Particles are moving all the time. Number 3. The freedom of movement and the arrangement of particles is different for solids, liquids, and gases. Number 4. The pressure of gas is produced by the atoms or molecules of the gas hitting the walls of the container. More frequency of collision equals higher pressure. Heating curve. In a heating curve, the temperature increases. Particles move further apart. Intermolecular forces between particles decreases. From A to B, it is a solid. B to C, it exists as solid and liquid, melting. C to D, it is a liquid, melted. D to E, it exists as liquid and gas, boiling. E to F, it's a gas. 15 degrees Celsius is the melting point. 80 degrees Celsius is the boiling point. Note that S stands for solid, L stands for liquid, and G stands for gas. Between B and C, and between D and E, there is no change in temperature as the substance is absorbing heat to break the intermolecular forces so it can change its state. Cooling curve. In a cooling curve, the temperature decreases. Particles move closer. Intermolecular forces between particles increases. From A to B, it is a gas. B to C, it exists as gas and liquid state, condensing. C to D, it is a liquid. D to E, it exists as liquid and solid, freezing. E to F, it's a solid. 15 degrees Celsius is the melting point. 80 degrees Celsius is the boiling point. Note that S and G stand for solid, liquid, and gas. Between B and C, and between D and E, there is no change in temperature as the substance is releasing heat and intermolecular forces are being formed to contain its state. Temperature and pressure. Number 1. As temperature increases, the kinetic energy of the particles increases. Number 2. As kinetic energy of the particles increases, the particles move faster. Number 3. As the particles move faster, they collide with the wall of the container more frequently. Hence, the pressure also increases. Number 4. Pressure can also be increased by decreasing the volume, so the particles can collide more frequently. Congratulations, we have finished 1.1. Moving on to 1.2. 1. Describe and explain diffusion in terms of kinetic particle theory. 2. Describe and explain the effect of relative molecular mass on the rate of diffusion of gases. Diffusion is the process by which different fluids, gases, or liquids mix as a result of their random motions of their particles. Particles move from a region of higher concentration to lower concentration until the particles are evenly spread. Rate of diffusion in liquids is slower than in gases. Diffusion does not take place in solids. Can you think of any real-life examples of diffusion? Drop your answers in the comments. Perfume is an example of diffusion. How? Well, imagine you spray perfume in one corner of your room. At first, only the air right around the spray smells nice, but after a few seconds, you can smell it all the way across the room, even though you didn't move the perfume at all. That spreading smell is called diffusion. Relative molecular mass on the rate of diffusion of gases. The question states that when the two gases meet, they react to produce a white solid, ammonium chloride. Where will the solid be formed? Note that the greater the molecular mass of a gas means that it is more heavy, so it will travel a less distance. In this question, we have hydrochloric acid, or HCl, on the left side, and ammonia, or NH3, on the right side. The molecular mass of HCl is 36.5, and the molecular mass of NH3 is 17, which means that hydrochloric acid has a greater molecular mass, so it will travel a less distance compared to ammonia. Hence, solid will form at A. Question time. Pause the video to answer the questions. Answers are at the end of the video.